Welcome back, students. So, question number 19 will be our last question of the day, but I want to take a little bit of time on it. So, here we go. Question 19 says, what does it mean that insulin and glucagon are antagonists? And I don't have the rest of the question in front of me, but basically, what are their targets and how do they accomplish these different functions? So, basically, when we look at the pancreas, and I think you guys are pretty familiar with this, the pancreas being the endocrine organ, endocrine gland that releases the insulin and the glucagon hormones in response to changes in blood sugar levels, blood glucose levels. They're considered antagonists because basically they do exactly the opposite thing as one another. Okay, so insulin allows glucose to be taken out of the blood, glucagon allows glucose to get back into the blood. Okay, so our goal is to maintain sugar homeostasis, blood sugar homeostasis. So let's talk about a little bit more of how they do that. Okay, so you have a homeostatic diagram right here. So let's take a look at, the body when you have just eaten, let's say, some jelly donuts, okay, for breakfast. And so your blood sugar is now at an imbalance because we have just flooded the blood with sugar from your meal. So that elevated blood sugar level will be a trigger for the hypothalamus and for the pancreas to, basically stimulate and those cells that release insulin into the blood. So insulin acts on the target organs of the liver and then the tissue cells in the body. And since all the body cells need glucose to make ATP, then basically insulin is going to target a lot of different groups of body cells for that. So basically, insulin acting on these cells causes them to uptake glucose from the blood. The liver, we've talked about before how the liver takes up glucose and then stores it as glycogen. All right. So once we've removed glucose and put it into the liver and into the tissue cells in the body, then that blood glucose level falls back to that normal set point, and that stimulus for the insulin release diminishes. So basically, that's a negative feedback to that pancreas saying, okay, we're done with insulin. Go ahead and stop producing it because the blood glucose level has been has been reestablished rather. So let's say you're, sitting in class, it's right before lunch, you start to get that hunger impulse. All right. And so the blood glucose level has dropped and you are ready to eat again, but you have low blood sugar right now. There's going to be that same message response. Basically, the hypothalamus realizes it. The pancreatic cells realize the low blood sugar level. And so now a different group of cells is stimulated to release glucagon into the blood. So basically, that travels to the liver and says, hey, remember that glucose that you stored as glycogen? We need it back. We need it into the blood. So that target of the liver, that glucagon targets the liver, goes in, breaks down those glycogen storage reservoirs, and that glucose is now freed up to go back into the blood. So the blood glucose level rises and the homeostatic balance is restored. And basically, this happens over and over throughout the whole day. You have a rise in blood sugar and a drop in blood sugar. And these two hormones perform the exact opposite functions of each other. So they are antagonistic. So hopefully that will help.